Welcome to The Explainer. Have you ever wondered how sending a bit of crypto to a friend actually works? Like, how does that single piece of information get securely locked into a global, decentralized record book? Well, today, we're going to demystify that exact journey.
So, let's dive right in. I want you to imagine a shared digital notebook that millions of people all over the world can see and use. The catch? There's no one in charge. No editor, no boss, nobody calling the shots. This brings up a huge problem, right? How do you decide who gets to write the next entry without the whole thing turning into chaos?
Before we can figure out who gets to write in the notebook, we've got to know what exactly they're writing. It all starts with the smallest, most fundamental piece of the puzzle,
And that piece is called a transaction. At its core, it's super simple. A transaction is just a record that something happened. In our notebook, it's literally the sentence, Alice paid Bob $10. It's a single, verifiable fact that we want to add to this permanent record, forever. And here's what's so cool about it. It is not just about money. A transaction can represent almost any kind of digital info you can think of. It could be a record proving you graduated from college, a digital title proving you own a piece of art, or even a log entry showing that a shipment of coffee made it from the farm to the warehouse. The possibilities here are absolutely huge. Okay, so we've got all these transactions just waiting to be recorded. But in a network with millions of people, who actually gets the authority to write them down on the next page of our shared notebook?
This is where a very special group of people called miners comes into play. You can think of them as the volunteer scribes of the network. They connect these incredibly powerful computers, and their whole job is to compete against each other for the honor of adding the next page, or what's called a block, to the chain.
Now, to keep everything fair and totally secure, miners don't just, take turns. That would be too easy to cheat. Instead, they have to earn the right to write by competing in this massive, ongoing digital race. It's almost like the network itself is a game show host, shouting out to all the miners at once. All right, everyone, I've come up with an impossibly difficult secret code. The first one of you to crack it wins, and you get to add the next block of transactions. So how does this race actually play out? Well, it happens in 3 basic steps. First, a miner grabs all the latest unconfirmed transactions and bundles them into a potential new page. Then, the real work begins. They fire up their computers to make literally trillions of guesses every second to solve that cryptographic puzzle. And finally, the winner, the first one to find the answer, gets to broadcast their solution to the entire network. This whole competition has a name, proof of work. And the name is just perfect because the winning miner has to provide actual mathematical proof that their computers spent the energy and did the computational work to find that answer. It's not about being the smartest or the luckiest, it's about provable brute force effort. Okay, so one miner wins the race. Fantastic for them. But how does their single victory become an accepted fact for the entire global network? How does their one page get added to everyone's copy of the notebook, all at the same time? And this, right here, illustrates the absolute genius of the system. While solving that puzzle is brutally difficult, requiring just massive amounts of computing power, checking if the answer is correct is incredibly fast and easy for anyone else on the network to do. So, picture this. The moment a winner broadcasts their solution, the rest of the network acts like a giant jury. Everyone, independently, takes a quick look and verifies the winner's work. If it all checks out, and it only takes a split second, they all accept the new block and officially add it to their own copy of the blockchain. The notebook gets updated, all at once, by everyone. This amazing process of everyone coming to an agreement is called consensus. And this is the magic trick that solves the whole problem of trust. It's what allows millions of strangers with no central boss to collectively build and maintain a single, identical, and completely trustworthy record of everything that's ever happened. Which, of course, brings us to a really, really important question. Miners are spending a ton of real-world money on powerful hardware and paying massive electricity bills to solve these puzzles. So why on earth would they do that? What's in it for them? The answer is probably the one you're thinking of. It's simple. They get paid. For all that effort,
For winning that insane digital race and for securing the network, the winner receives a very valuable reward.
And that reward actually has two parts. First, the winner gets a prize of brand new cryptocurrency, like Bitcoin, that was literally just created out of thin air. And on top of that, they also get to collect all the small transaction fees that people included with their records in that block. This two-part reward is the economic engine that powers the entire network security. It's what makes sure there are always scribes competing to honestly update the notebook.
Okay, wow. That was a lot to take in. Let's do a super quick recap of the key terms we just learned, just to make sure everything really sticks.
All right, let's lock this whole journey in. The entire process begins with a transaction, that single line item we want to add to our global notebook.
That transaction then gets scooped up by the miners, our network's dedicated scribes, who are all competing for the chance to write it down.
The competition they're in is called proof of work. It's that massive digital race to be the first one to solve the network's incredibly hard puzzle. And finally, the winner's new page becomes official for the whole world through consensus, the democratic process that keeps everyone's copy of the notebook perfectly and permanently in sync.
So now we've seen the how, we understand the mechanics, and that leaves us with a much bigger, more profound thought to chew on. What are the true implications of having a permanent, trustworthy global record that no single person, no company, and no government can ever control? That right there is the revolutionary idea at the heart of it all.